Welcome to this comprehensive Python tutorial, where we'll dive deep into the different types of loops. Loops are powerful tools that help us handle repetitive tasks efficiently, and mastering them is key to writing clean, effective code. Let's begin with counter-controlled loops. These loops are used when you know exactly how many times you need the loop to run. For example, imagine you're asked to print the numbers from 1 to 5. You can use a for loop with Python's range function, like this. For I in range 1, 6. Print I. Here, the loop starts with the value 1, increments by 1 each time, and stops after 5 iterations. It's perfect for tasks like counting, summation, or iterating through a fixed list. Now, let's move to condition-controlled loops. These loops run as long as a specific condition is true. Unlike counter-controlled loops, the number of iterations is not predetermined, it depends on the condition. For example, consider this while loop. Count equals 1. While count equals 5. Print, count. Count plus equals 1. In this case, the loop will keep running until the count variable exceeds 5. This is great for scenarios where the stopping point depends on dynamic conditions, like validating user input. Next up is the Sentinel-Controlled Loop. Sentinel loops stop when they encounter a special value, often called the Sentinel. Imagine you're writing a program that repeatedly asks for user input until the user types exit. Here's how it works. While true. Value equals input, enter a number, type exit to stop. If value equals exit. Break. Print, F you entered, value. This type of loop is especially useful in scenarios where you're processing unknown amounts of data, such as reading input until a specific termination signal is given. Now let's discuss infinite loops. These loops run indefinitely unless you manually stop them or include a break condition. For instance, in game development or server programming, you may want your application to keep running to handle user inputs or events continuously. Here's an example of a simple infinite loop. While true. Print, this runs indefinitely. Be careful with infinite loops, they're powerful, but can cause your program to freeze if not handled correctly. Always include a way to exit the loop safely. The fifth type is the event-controlled loop, which is designed to stop when a specific event occurs. For instance, consider a guessing game where the user tries to guess a randomly generated number. The loop will stop once the correct number is guessed. Here's how it might look. Import random. Target equals random.randint, 1, 10. While true. Guess equals int, input, guess the number, 1 to 10. If guess equals target. Print, you guessed it. Break. Print, try again. This type of loop is excellent for scenarios where the stopping point depends on a real-world event, like user interaction. Finally, let's explore a special case of the counter-controlled loop. In Python, you can write the initialization, condition, and update all in one line using list comprehension. For example, to print numbers from 1 to 5, you can do this. Print, I for I in range, 1, 6. This method is concise and elegant, and it's ideal for generating lists or performing operations where you don't need to process each iteration individually. By understanding these different loop types, you'll gain the flexibility to tackle a wide range of programming problems efficiently. In this video, we'll not only explain these concepts, but also demonstrate practical examples for each type to help you implement them in your own projects. Now that we've covered the basics, let's dive into the code and see these loops in action. This program demonstrates how to use different types of loops in Python to create a useful and interactive tool. Let's break it down, step by step. First, we initialize our task tracker with an empty list called tasks. This will store all the tasks that the user adds or modifies. Step 1, counter-controlled loop. When the program starts, we use a counter-controlled loop to add 5 sample tasks to our list. This is done using a for loop that iterates from 1 to 5, appending a new task in each iteration. It's great for automating repetitive tasks, where the number of iterations is known beforehand. For example, For I in range, 1, 6. Tasks.append, f sample task, I. After this, we display a message confirming that the sample tasks have been added. Step 2, infinite loop, the main menu. Next, we display the main menu using an infinite loop. This loop keeps the program running continuously until the user decides to exit. The menu presents 5 options. View all tasks. Add a new task. Mark a task as done. Delete a task. Exit the program. Here's the key part. While true. Print \n task tracker menu. Print 1. View tasks. Print 2. Add task. Print 3. Mark task as done. Print 4. Delete task. Print 5. Exit. Choice equals input, enter your choice, 1 to 5. Step 3, condition-controlled loop input validation. To ensure the user provides a valid menu choice, we use a condition-controlled loop. This loop continues asking for input until the user enters a number between 1 and 5. For example, while choice not in 1, 2, 3, 4, 5. Choice equals input, invalid choice. Please enter a number between 1 and 5. This ensures the program handles invalid inputs gracefully and avoids errors. Step 4, Sentinel-Controlled Loop, viewing tasks. When the user chooses to view tasks, we use a Sentinel-Controlled Loop to iterate through the list of tasks. The loop stops automatically when there are no more tasks to process. Here's how it works. For task in tasks, print f task. If the list is empty, the program lets the user know that no tasks are available. Step 5, event-controlled loops, marking or deleting tasks. When marking a task as done or deleting a task, we use an event-controlled loop. These loops wait for a specific event, like the user entering a valid task number, to proceed. For example, when marking a task as done. While true. Try. Task_number equals int, input, enter the number of the task to mark as done. If 1 equals task_number equals len, tasks. Tasks, task_number 1, plus equals, done. Print, f task, task_number, marked as done. Break. Else. Print, invalid task number. Try again. Accept value error. Print, please enter a valid number. This loop ensures the program won't proceed until the user provides a valid number. Step 6, exiting the program. When the user chooses option 5, the program gracefully exits by breaking out of the infinite loop. If choice equals 5. Print, exiting task tracker. Goodbye. Break. Bringing it all together. By combining these loop types, we've created a robust and interactive program. Each loop serves a specific purpose. Counter-controlled loops automate predictable tasks like adding sample data. Condition-controlled loops validate user input. Sentinel-controlled loops process lists of tasks. Infinite loops keep the program running. Event-controlled loops ensure user actions are valid before proceeding. This project is a practical and beginner-friendly way to understand how loops can work together to build real-world applications. Give it a try, and feel free to expand the functionality further. And that's it for this tutorial. Thanks for watching, and happy coding!